12.8, represent problems on a coordinate plane. Now, in another unit, we'll have more about graphing and plotting ordered pairs and different things and what all those words mean. The focus for this one is going to be in a real-world situation, sort of interpreting line graphs and understanding what they mean. There'll be a little bit, the first one, I can plot points that represent real-world situations, and then I can interpret coordinate values of points in the context of the situation. So again, a lot of like real-world situations, not just here are these points, graph them. So the first problem, Aaliyah is at the 30th floor of a building. While waiting for the elevator, she collected the data shown in the table. How many minutes will it take the elevator to reach Aaliyah's floor? So really think about like picturing around like what's happening. Okay, she's waiting on the 30th floor. The elevator must be coming up to her. So she's timing in minutes how long it takes it to reach each floor. So at 0 minutes, it's at the it's at the bottom floor. After 1 minute, it's at the 5th floor. 2 minutes, 10 floors. 3 minutes, 15 floors. 4 minutes, 20 floors. So then notice there's this pattern that we can use to help us predict when it will get to her on the 30th floor. Now you might already be able to tell through one method or another, but we're going to look at how putting it on a line graph can help us visualize and see the pattern that's happening. And we can use a line graph because we are showing data over time. And anytime we have data over time, we can use a line graph. So first we can write them as ordered pairs. Now ordered pairs are just the two numbers that I use to graph. So next to the graph, I want you to write X, comma, Y. So on a graph, there's the X-axis and the Y-axis. And the X-axis comes first, and then we have the number on the Y-axis. So in your chart, go ahead and write 0, 0 is our first one. I just got them from right here. So we have time, then floor. So in parentheses with that comma in between, showing me the X number and the Y number. It'll be how far I go over and then how far I go up on my graph. I am going to have you plot it with me in a minute, but you won't have to do a ton of graphing, but starting to get that in your brain because again, we'll revisit it in another unit. The next one is 2, 10. Then we have 3, 15. I have to scroll, but my pen won't scroll, so make sure you have that. Pause if you need to, and then I'll do the other ones. Oops. There we go. I should have used that pen. Oh, just one more. Just for 20 on the last one. So again, those are called my ordered pairs. X, Y, it's in alphabetical order. X comes before Y. How far you go over, how far you go up. Time is the X coordinate. Floor is the Y coordinate. The time will always be on the X in a line graph. So months, days, years, minutes, seconds. Those will always be on the X, and whatever else will be on the Y. So there's the one we just wrote. The pairs we just wrote. Now we are going to plot the points. So you have this on your paper as well. So the first one, 0, 0. We go over to 0, up to 0. So it's just right there on the bottom. Sorry, I guess, do I need to switch to my pen? Oh, there we go. I'll switch there, I think. Okay, well, I'll just use this. Sorry, I don't know why it was being all weird. But 0, 0 is on down here. I didn't go anywhere to the right. I didn't go up. Now 1, 5, I go over to 1 and I go up to 5. So sometimes people will like trace with their fingers like that. Now I'm not going to draw those lines, but that's what you can kind of do if you need to. So next one is 2, 10. So over to 2 and up to 10. Then we have 3, 15, over to 3, then up to 15. Notice how this is counting by 5s. So I'm going up to the next multiple of 5. Obviously, graphs can count by a lot of different things. Next, we're going to go over to 4, up to 20. So there's our points. Make sure you have that on your paper. It says this on there, but you may want to make it bigger, that this is the x-axis and this is the y-axis. The x lays flat, the y is up in the air. And then we can even answer questions about our graph and use it to help us predict patterns. Like we said, she was on the 30th floor, so I can extend it to see when it would get to her. Can help us interpret the data. So then we'd connect them. If you didn't already do that, you can connect them. And then we can even extend it, continuing in the same pattern. Not all line graphs will be a straight line, but this year they will be. They'll be all linear, which means they'll be a straight line. And then what floor was the elevator on at the beginning? How do you know? Well, think, okay, the beginning, that's 0 minutes all the way at the beginning. So if I go find that data point, 0 minutes at the beginning, it was at the ground floor, 0 floor. And again, the point tells me that that's where it was. Now we can continue our pattern on like we did, and then we can say, when will it get to the 30th floor? Well, I can go over and see, well, where does the line hit that 30th floor? It hits it right there, and then if I follow that down, that's at 6 minutes. So I can say, at 6 minutes, this point right here tells me it'd be at the 30th floor. Just like at 5 minutes, it was at the first floor. I can even add another point here. I know it doesn't ask. And say, at 25 minutes, it was at 5 minutes, it was at the 25th floor. Notice how I accidentally mixed those up. You need to be really careful to make sure you have your which is on which axis straight. So 5 minutes, 25th floor. Or 6 minutes, 30th floor. So seeing those patterns are easier to see visually. 6 minutes to reach the floor. So we can represent real-world problems by plotting and connecting points on the coordinate plane. Coordinate plane is just like the graphing area. We can interpret what the points mean, which can help us understand the real-world problem. So I'll do this one, and then I have some questions for you to try. So this graph represents the beginning of a roller coaster ride. What do you think happened between 2 seconds and 4 seconds? So if we look on our graph, find our seconds, and say, okay, our seconds are down here, right? So 2 and 4. Well, if I scroll on my graph, 2 is right here, 4 is right here. So what happened from here to here? Well, this tells me height, so it looks like they started at 40 meters, went up to 50 meters, and then went back down to 40 meters. So if you can think on a roller coaster, that part where you go up to the very top and then start dropping, that must be the part that happened from 2 seconds to 4 seconds. I can tell that by looking at my graph, thinking about, okay, Make sure I'm on the right axis. I didn't look 2 and 4 down here because this is meters. That would be 2 and 4 meters. I looked for the seconds since that's what it asked about. And then I looked at the points that matched that time, saw how they changed. Yes, climbing, then dropped. All right, the next one, they're going to give you some points. So the first thing, all right, the table shows the time it took for a 5th grade student to go down the slide at a park and their height from the ground while going down the slide. So picture, okay, they're going down a slide. Hopefully you've had experiences or seen somebody do that you can connect to in your mind that will help you understand what's happening. So we have the time in seconds, the height they were at each second. So I want you to choose in the multiple choice which option matches, which set of ordered pairs matches the data that is right here. All right, hopefully you chose right. We have 0, 7, just the time and then the height. 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. This is kind of nice because it switches the numbers. You have the reverses of each other. But hopefully you chose that. If you still don't get how those points match, ask, please. Now, plot and connect the points. I went ahead and did that because you can't, there's not an easy way to do that on a multiple choice thing. But you can see I did 0, 7 is up there, 1, 5, 2, 4, 3, 3, 4, 2, and 5, 1. So I made sure to go over first and then up. The main difference is where that 0, 7 ends up. Now we're going to do some interpreting of the data. One second, I need to go back a second, or else we're going to do the questions backwards. Okay, how tall is this slide? Go ahead and choose. All right, hopefully you got 7 feet because at 0 seconds, that's where they were. So at the beginning, they must have been at the top. That is what makes the most sense. How long does it take the student to go down the slide? Go ahead and choose. All right, hopefully you said 5 seconds because they're at 1 foot after 5 seconds. Most slides, sorry, you may have seen it was low. We're good. Most slides sort of end a little bit off the ground, and it's our last data point, so we can assume that the 5 seconds was the end. What happens between 0 seconds and 1 second? Go ahead and choose. All right, there's different ways to think about this, but hopefully you chose the one that talks about how they go down 2 feet, right? They went from 7 feet to 5 feet. They dropped that initial incline. They went down 2 feet. They started to go down. Are some of the things you could have said if you were just writing your answer, right? And then where is the student after 5 seconds? Go ahead and choose. All right, hopefully you said 1 foot off the ground because we can see 5 seconds, 1 foot off the ground. All right, if you have questions, make sure you ask. Good luck.